There are two friends playing with their cell phone and talking to each other.
Whew! My cell phone has low battery. I need to charge it immediately. Wait,
Wait, I wonder how electricity can charge our cell phone.
hmm. Let me think of it.
Go!
Sorry. Hey, you're here!
It's okay.
We're wondering how electricity can charge the battery. Anyone you can do it?
Are you two wondering what is the purpose of electricity and how it can charge the battery?
Just tell us, bro.
Electricity is a set of physical phenomena associated with the presence of electrical charge.
What? What do you mean?
Electricity is a natural force that we've harnessed for our energy needs. To understand electricity, we need to know a little more about atoms, the tiny particles that make up our universe. Three smaller particles make up atoms: neutrons, electrons, and protons. Electrons have a negative charge, protons have a positive charge, and neutrons are neutral. The center of the atom includes neutrons and protons, while the electrons orbit the center like the Earth orbits the Sun. Stable atoms have an equal number of protons and electrons and have no charge. If a material holds on to its electrons tightly, it is known as an insulator. If its electrons are more loosely bound, it's called a conductor. When a large number of free electrons pile up at one end of a conductor, particles that have the same charge repel each other, while particles that have opposite charges attract. These negative electrons push each other apart, jumping from atom to atom through the conductor, creating electricity. There are two forms of electricity: current and static. Current electricity travels. It is composed of flowing electrons passing from one atom to another through a conductive material. It is this form of electricity that powers our homes. Static electricity is a charge at rest on an object. Sometimes your body picks up extra electrons through friction and becomes negatively charged. When you touch a conductor, like a metal doorknob, you experience a small shock as the static charge jumps from your body to the doorknob.
It is considered as separate to magnetism. Later, I will tell you what magnetism is.
Okay. Let's go back to electricity. Various common phenomena are related to electricity, including lightning static, electricity, electric heat up, electricity discharges, and many more.
It means that it is a heart of a technology.
Yes, it is. Without electricity, you can't use gadgets or appliances that needed electricity. We are in modern generation, meaning more technologies has been arrived.
More. As of now, everything we see has technology in there. So, even in working, technology helps people in working so that it can make easily produce or finish.
Yes, absolutely. In continuation of electricity, electricity can be either positive or negative. Electricity produces electric field. On the other hand, the movement of electric charge, also known as electric current, produces magnetic field.
Wait. Did you say that? It is positive or negative? Then why the outlet of electricity can plug in it vice versa?
In your question, there is called no polarity and polarity. When you say polarity, it has two kinds of electrical charge, the positive and the negative. The best example of it is battery. While non-polarity, it is just like example, your outlet. You can plug in any kind of appliances on it without thinking of its polarity because it doesn't have that kind of electrical charges. That's the non-polarity.
Oh, okay. But you said earlier that magnetism and electricity separate each other. How come? Ah, yes. Magnetism is a class of physical phenomena. Um, so magnetism is the one who rises in the magnetic field to help it produce. It produces together with electric current.
If you take a piece of wood and put it next to another piece of wood, nothing happens. And if you take a piece of granite and put it next to another rock, still nothing. But if you take this piece of iron and put it next to this other piece of iron, magic. I mean, magnet. Magnetic objects are able to magically attract at long distances because they generate magnetic fields that extend invisibly out beyond the object. But the mystery is this: where do magnetic fields come from?
Well, that's easy, Henry. We've known for a long time that electricity and magnetism are really just two sides of the same coin. Kind of like mass and energy or time and space. They can be transformed into one another. And in fact, a magnetic field is just what an electric field becomes when an electrically charged object starts moving.
That makes sense for explaining why a current of electrons flowing through a wire causes this compass needle to move, or how currents in the Earth's outer core generate the geomagnetic field. But a bar magnet or the compass needle itself are just pieces of metal without any electrical current running through them.
Or are they? At the microscopic level, there are loads of electrons whizzing around the atoms and molecules that make up any solid.
Right, this brings up an excellent point. The magnetic behavior of any everyday object is influenced by a fascinating combination of effects ranging from the level of particles to atoms, collections of atoms, and collections of atoms. First, individual particles. Unlike the everyday workings of gravity and electricity, permanent magnets can only be fully understood as a quantum mechanical effect, in much the same way that particles like electrons and quarks have fundamental properties called mass and electrical charge. Most particles also have another intrinsic property called tiny magnet. Just kidding, it's called intrinsic magnetic moment, but really that's just technical mumbo-jumbo saying that particles with electric charge also happen to be tiny magnets.
Aside from magnet, speaker is one example. Speaker is a device that uses electricity and magnetism.
How come?
Speakers convert electrical signals to motion, which then makes the sound wave. That coil will move when there is a current flowing through, and the magnetic field perpendicular to that current. Magnetic field comes from magnet, usually a single magnet.
Whoa! All of you are so smart. So since all of you are here, we should play together.
Okay, but I'll be using my time consciously because I need to study.
Alright.